Okay, so let's wrap up our discussion of section 5.1 with a couple of examples. Now this first one is based on finding the coordinates of the points where a line intersects a circle. So what we're really doing is, and I'm going to walk you through building this picture, so don't worry about it too much. But at base, what we're going to be doing is finding the coordinates of the points where that line that I've drawn in black intersects the circle that is drawn in red. So now let's talk about how I built that schematic. So my problem says that a small radio transmitter broadcasts in a 53-mile radius. If you drive along a straight line from a city 70 miles north of the transmitter to a second city 74 miles east of the transmitter, during how much of the drive will you pick up a signal from the transmitter? Okay, so the first thing I did was I made a decision. And the decision I made was to put my transmitter right here in the middle at the origin. What that does for me is that centers my circle at 0, 0. That also fixes my coordinate system for the rest of my problem. So that means that my town up here is at the coordinates 0, 70. And my town to the east is at the coordinates 74, 0. So now what else do I need? If I'm going to write the equation of that circle, I need a radius. And I'm told in my problem that my radius is 53. So now I can write the equation of the circle. And the equation of the circle is 53 squared equals x minus 0 squared plus y minus 0 squared, or we can write that just as 53 squared equals x squared plus y squared. Now I need the equation of that line. Because in order to answer this question, what I really need are the coordinates of these 2 points where the line intersects the circle. And then I need the distance in between them. That distance is the actual answer to my question. But we're going to start with the equation of the line. So you might or might not remember, but there is an equation of a line. So I'm using the point slope form, which says that y minus y1 is equal to the slope times x minus x1. This is the equation of a line that goes through the point x1, y1 and has slope m. So my slope m is the difference in y's divided by the difference in x's, which is negative 70 over 74, which simplifies to negative 35/37. So in this case, so I could use the point slope form of the equation of a line, but I can also use y equals mx plus b, and that's relatively simple because my b is 70, so my line is negative 35 over 37x plus 70. The equation of my circle and the equation of my line. Now, in order to find where those two intersect, I'm going to substitute this expression into y in the equation of my circle. So now I am finding the coordinates where the line and the circle intersect, which means that 53 squared equals x squared plus negative 35 over 37x plus 70 squared. Now that's a quadratic equation with one variable. You have the tools to solve that. These numbers are rather obnoxious, so I'm going to show you how to use Desmos to solve this. So Desmos is my favorite graphing utility. There's a link to it in the course shell. And I have this problem set up here in Desmos. That red circle is my circle. The blue line is my road. And then this is the point north, and this is the town east. So what I did to make those show up was I simply touched that point on my graph. Now I'm on a touch screen, so I can touch. If you are on a PC, you can click. And what I'm going to do is I'm going to touch on this point right here where the circle intersects the line. And if I touch on that point right there, the lower one, the one that's to the below and to the right, I can get the coordinates of my intersection points. And that's what I've got right here in my notes. So what I want, so now I know that my x, so what that means is that when I solve this equation, I would have gotten x equals 24.098 or x equals 45.794. Plug those x's back into either of my two equations and I'd have gotten the corresponding y coordinates. So where am I? Well, remember what I need. I need this distance in between those 2 points. So I need distance equals the square root of the difference in x's squared plus the difference in y's. Squared. And if I run that through my calculator, and Desmos works just fine as a calculator, so I've done some fancy stuff up above here, don't worry about that. What I want is the square root of 24.098 minus 45.794. Go outside my parentheses and square that. Add to it 47.205 minus 26.681 quantity squared, and I get a distance of 28.176 miles. So for 28 miles of my drive, just a little over that, I get radio signal. All right. I'm going to stop this recording, and then I'll come back and do one last example in another recording.